Hey everybody, this is Alejandro Perez with CGI Nerd. In this video we're going to take a look at some of the basics of particles and create a confetti blast. Let's get started. Here we are going to create a geometry node. This is going to be our confetti. And we're going to create a circle. This is going to be our emitter. This is fine. I just want to change the plane and reverse so that way it's pointing that way. And that's what's going to launch up the particles. So we need to create a particle or a particle network. So it's pop network. You can create that. Visualize this. Double click here and you can see that it's creating particles. So now we're using the first context geometry, so that's perfect. Attributes, we want it to move up. So let's do that. Then go to birth, attributes, and then we're going to add initial velocity. And you can see that by default, this is kind of what it's looking like. It's got a random velocity in all directions. So we want it to go up. So I'm going to make the force in the Y be much stronger. And you can see that it is shooting up. Eventually it'll come down. Let's put this real time. So that looks good. Now we want to add some atmosphere and gravity. So let's add gravity first, because right now the force is just pushing out and not being affected by gravity. So gravity force. And connect it there underneath the pop solver. You can see that it comes out that way. So I want it to spread out wider. So on the force here, we can add more variance on the X and Z so it pushes out in more directions. So let's say like 5 and 5. And let's add a variance here of like 3. There you go. The only problem now is that they're falling down into infinity. So let's add a ground plane. So ground plane. And we can add a merge. We'll add this underneath the pop solver. So we'll put this here and then put that there. Disconnected, so let's do that. And then we'll put the ground plane coming in first. You can see that the particles are bouncing quite a bit. Eventually they kind of slow down and stay there. And then we have the particles emitting forever. So on the birth, if we go to constant activation, let's say that it activates for like 5 frames. Oops, not that one, but here. And then on the next frame, we turn it off. So 0 is off, 1 is on. And then we can see kind of how bouncy they are. So the ground plane has some physical attributes. We can decrease the bounce here. And then also on the particles, the pop object, we have physical and we have bounce here. So let's put this at like 0.3. So that way they're not completely like sticking. Maybe we should put this at like 0.5. Because I don't want it to stick. I just want it to like dampen pretty quickly. So that's too much. And just play with the values until we get what we want. That looks okay. So now we're going to want a geometry to connect to these particles. So let's create a grid. And then this is going to be our null node, so that way we can connect to an out network. So we're going to say out confetti. Okay, so I want to keep this really low resolution because it's going to be tiny. And let's put it at like let's start off with 0.1. And then let's do a copy to point. And then we have the geometry to copy, which is going to be the confetti, and then the points. So something to notice is that there's already points here on the grid because we created that ground plane. So we have to go in and fix that. Let's create a blast node. We basically want it to blast the ground plane and not the particles themselves. So here we can see that the particles end up being kind of vertical. And there's no thickness. You can give it a thickness. I'm going to do that here, but it's not like completely necessary. Let's do a poly extrude and 0.001 and output the back. And let's visualize this really quick so we can see what that looks like. It will kind of slightly affect the render to make it look nicer because it has an edge, a thickness. The other thing is now, let's get to the point where it's at the end. You can see that they all kind of end up vertical there because of the alignment of this. So let's try, there we go, different alignment here, which will affect the way it's created here, but it makes it look right here. And then you can see that they're kind of like rotating, but they're rotating based off of the velocity, and they're all doing the same kind of rotation. So we might want to kind of add some variation to these. Okay, so I think that looks better. And let's look at adjusting the rotations. So we can do that with a point VOP. And inside of the point VOP, we can adjust a attribute but with a bind export. So in here we need a 4 vector, and we're going to call it ROT, which is going to affect the rotation. This is based off of a quaternion, so if we bring in a quaternion, we can adjust that there, and then based off of the axis, rotate this. So you can see that here we're rotating along the x-axis. Here we are going to be rotating, if we look closer, along the y-axis. And then we could have the z-axis as well. There we go. So that's essentially how that works. I'm going to start off by setting a kind of offsetted rotation for everything. So I want it to go on the y because if we look at it, everything is kind of lined up exactly where we want it. And let's take this and adjust the angle based off of the point number. So we have the point number. Let's put this into a multiply node. And let's, actually we don't even need a multiply node for this in particular. So let's take this point number and randomize it. And that's going to give us a number between 0 and 1. So we can do a fit range and take the value here. And let's say we go from 0 to 360. And then connect that into the angle. So we can see that now there is a randomness to all the confetti there. And if we look at the scene as a whole, we can kind of see what's going on there. This looks good. Let's end this at about frame 75. Okay. Great. Okay, so now let's add more rotation as they are kind of going together. So just gotta go back in here. Let's do we're going to do something kind of similar to this. We're going to take a multiply node and connect that into, actually we don't need to connect that into anything. We're going to take the, generate a random number from the point number, and we're going to basically multiply the velocity by that random point number. And then we're going to do a fit range again. And then we're going to take this, let's copy another quaternion. So let's look at what this looks like right here. So there's going to be more rotation, but you can see that at the end it's kind of just staying there, and it's also only rotating on the x-axis. We can also add another constant number as like a multiplier here, so let's do that. Let's do a constant value. Let's put this at, say we wanted it to rotate even more, oops, and add that as a third number to be multiplied to. Okay, so we should see it kind of spinning even more, but again, it's only on that one axis. So we want to be able to randomize the axis in which it's in. So we just have to, let's see. So we have those elements there, then we can add a add node. We are going to add that together with this. And let's see, it should give us the randomness of the positioning at the end. And then we want to randomize the direction in which this one is working at for the quaternion. So we have the angle where it's only going in the y-axis, so we want it to randomly add axes to each one. So this is a vector 3, so let's do a float to vector. So we get 3 floats and we can connect it to that vector here. And then let's generate a random number based off of the ID. And then connect that there. And we want to do a fit range. And the random will give us a number between 0 and 1, but we want it to go from -1 to 1, so that way it will potentially like randomly rotate it in different angles. Okay, so we got that, and then we only have one of the axes, so now it's choosing a intensity in the x-axis, or a direction in the x-axis. We want to basically do the same thing for the y and the z. And we can base it off of the ID number or the point number. They should be different for each point anyways. And then we're going to connect this one here. And then we need a third one. Let's drag that down, holding down the Alt button. Now we have a random number based off of each one of the variations that we have. The only thing is that each one is going to be identical in the X, Y, and Z. So we can randomize that by kind of giving it a seed number. So we're going to want a constant, and let's give it 3 potential constants, and then let's do an add node. So we're going to take that, and let's create one for each one of these. And this one's going to connect to the out here and the out here. There we go. And then we can connect this here, and this here. And then each one of these constants, we can give it a different value. So like 255 and 90. So it will give us a different potential rotation. And you can see as we change it, we get a different rotational value for these numbers. And we can kind of like change it. You can see all of them kind of adjusting. Okay, there we go. So now that we've done that, we can go back and play it. You can see that we're getting kind of a more natural looking rotation. And here with this constant, like I said, we can make it where it rotates even faster. Oh, but it is actually still being fit ranged into there. So let's take this, move it, and put it here, and we'll put the multiplier afterwards. So we have the multiply there, and the multiply here. Okay. So you can see even here at the beginning, they're not all perfectly flat. Whereas if we were to just delete this here, the connection, it all changed. Boom. Okay. So let's put it here so that I can expand and see everything. So here, and maybe we can kind of multiply everything by time, and we'll do that here. So the time, or we could do it by frame, add that as a multiplication item here. Actually, instead of multiplication, yeah, we want to multiply it because once the velocity gets to 0, we want to make sure that it stays at 0. So the faster it's moving, the more it's going to rotate. And this is really kind of nice. We got the randomization. Cool. Okay, so let's go over here and then let's add color to these. So let's do an attribute randomize. And we are going to randomize the color, which is great. And we can see that we get a random color for each point, which is when we copy it to points, transferred over here. Another thing that you can do is instead of randomizing it up here, if you want, you can randomize it after the point to copy, and you can see that you get kind of like a nice kind of rainbow shimmery type of confetti. Depending on what you're going for, you can kind of get this look and then have each individual piece of confetti be its own color, or if you want kind of a rainbow shimmery look, you can randomize each point of the confetti itself and you get this kind of look. Actually, kind of, you can see that when we look at it kind of from further away, it's a little bit more muddy, but if you're up close, it looks better. Whereas if you have it on each individual one, we get it looking a lot more kind of distinct, like it is confetti. So I'm going to keep it here, but that's kind of like a preference type thing. Another thing that I'm kind of noticing is that I just want a lot more points, but we have already kind of worked out the whole confetti explosion the way we want it. We just want to add more points now, so we can just jump into the pop network, go to the first source input, and let's say instead of 5,000, so that's 50,000, 500,000. Let's take a look at what that looks like. So you can see that it's going to be a lot more pieces. You can see that there is some randomization here. Let me add a little bit more randomization on the attributes here for the velocity of it coming up. I'll keep that there. Let's see. I like that. And if we want also just to enhance our simulation, so here we want to add some more air resistance. We don't need that. That's just a merge. And then let's do a pop wind. And that's just going to add some kind of air resistance. So that is quite a bit of air resistance. So here, I'm just going to make the force that it comes out initially much stronger. Let's take this air resistance and let's bring it down, which means let's put this back at 10 so that's not too crazy. There we go. And let's put this at like 0.3. 0.3. Okay, let's look at how this is going to end up looking as confetti. It's looking overall pretty good. I kind of would like it to go out more. So on the pop net here, 10, 10, and 15. Okay, let's try that. Cool. Let's increase this to 15 and 15, 20 and 20. And if we wanted to, we can actually add something like a pop spin. And let's look at, you can see kind of the radius at which it is working on. It's going to be the Y. And right now the spin speed is at 0, but let's put 0.3. Let's make sure that it's not actually spinning any of the individual particles. Yeah, that's what it's doing. Okay, I don't want that, so let's remove that. Let's just leave it there. I think the confetti is looking okay at this stage. So then we have a confetti blast. Confetti popper? I don't know. Happy New Year. I think I do want to make the traction be a little bit stronger. There we go. And then at this point, all you got to do is render. But just so that we could see what this particular one looks like, because it's going to be kind of locked in, the speed limited by the computer. I'm going to do a Flipbook, which will go through and record a frame for each one of the sequences. And then we can see it in actual real time. Make sure that we like it. Okay. There we go. So now we have a confetti popper blast. Confetti blast for the new year. And that's it for the basics of particles and our confetti blast. I hope you enjoyed it. We'll see you guys in the next video.